And one thing else that I should exactly tell you, that if you take the Riemann integral of a function, you call it proposition or whatever, you take its absolute value, it should be less than or equal to this. Take the absolute value of the function, then integrate it, and then take the absolute value. The left side should be smaller than the right hand side. I can give lots of examples for this. You have this function, for example it is sin x or whatever, sin x or minus sin x. You want to integrate between this, let's say 1 to a to fixed value, let's say b. It means you are interested in this area. What is this area? Positive. When you go down, this area is negative. These two areas are same, so positive and negative becomes 0, and the absolute value of 0 is, so the left hand side is equal to 0. I evaluated the left hand side. Let us evaluate the right hand side. Right hand side says that first take the absolute value of the function. First take the absolute value, and when you do the absolute value graphically, what happens? You have something which is below x-axis. You have to translate it to the above the x-axis. Now this area is positive, this area. First you are taking absolute value, then you are integrating. Positive, positive. This would be, let's say, some value 2b. You can see. So this is the idea behind that. So fundamental theorem of calculus, also called the first fundamental theorem of calculus. So fundamental theorem of calculus, also called in short FTC. Sometimes it is called the first fundamental theorem of calculus, and usually it is called the fundamental theorem of calculus. So let us say that f is integrable. F is integrable on some interval a to b, and capital F is continuous on interval a to b and differentiable on, let's say, open interval a to b. I have small f, that is integrable. I have capital F, that is continuous on the closed interval, differentiable on the open interval, such that what happens, that when you differentiate the capital F, you get small f. It means what we call, this is the antiderivative of small f. To differentiate f, you get f of x. You integrate this, you get capital F of x. Then, for all x in your interval, what happens? You integrate your function, that is simply equal to capital F of b minus capital F of. This is what we call the fundamental theorem of calculus, or the first fundamental theorem of calculus. That is very easy, and we should at least know this thing for the exam point of view. Otherwise, we are not interested. What happens? And let me add one thing else. That thing might be important for us for now. It says that f is integrable on this interval, and we have capital F which runs from this closed interval to the set of real numbers, such that this capital F is equal to, you take small f and you integrate from a to x, then capital F is uniformly continuous on this closed interval. Is it making sense? Is this definition making sense or not? If it is making sense, then we should go ahead. It says that you have some f which is integrable, and you have capital F which is the integral of this from, let's say, a to x. Then this capital F must be uniformly continuous.
Sir, on the very first, f is integrable. I hit it because if you are f of x or u integrable, God is again.
Small f is integrable. And capital F is the integral of small integral. This function is integrable. You integrate it, you get capital F.
Okay.
And then capital F should be uniformly continuous. I am saying this thing.
Double integration of
It's integration. It's not. I have small f,
which is integrable.
which is integrable means I can integrate it.
See.
Then I am integrating exactly. I am getting capital F. And this capital F should be uniformly continuous. Okay, so let us do one thing. Let me write example here. You know very well that what is the integration of from 0 to, let's say, 0 to fix x. What is the integration? 1 upon x. 1 upon x, no? And you apply upper limit, 1 upon x, lower limit. Problem means I should redefine this thing. 1, it's going to be equal to. I was writing 0, there was a problem. That's why I am writing from 1 to x. The integral from 1 to x is going to be this one. Is this uniformly continuous from 1 to some x? You know very well 1 upon x is uniformly continuous, and when you are not near to 0. If I was writing near to 0, there was a problem.
Yes.
I removed 0,
Not
there is no any problem. So you can see by redefining the limits, you have something that is uniformly continuous. But on this limit, if I was supposed to write 0, there was a problem in that. So this thing is okay. Can I say that okay, when you deal with these things, there is always some good thing when it comes to proof. If I say uniformly to be Lipschitz, then it's also okay, I think. And we can prove this thing easily. What I can do, I can take f of x minus f of y and their absolute value. Can you tell me this thing would be what? This would be a to x f of t dt minus a to y f of t dt. Are you agree with this?
Yeah.
Can I merge these integrals and I write that okay, one integral is from a to x, another integral is from a to y. A to x, I am subtracting a to y, so I am left with y to x. So this would be y to x f of t
Times.
dt. This is absolute value.
Yes.
This is absolute value. This is absolute value. This is smaller than or equal to y to x f of t dt. Are you agree with this? Because this absolute value is outside, I am taking it inside, that becomes less than or equal to.
So yes.
I think agree. And I know very well when f is integrable, it must be bounded. So this is bounded by some fixed value m. So I am putting here m because it is less than or equal to m. Then I am taking m out. So this would be equal to m. Now I am integrating from y to x dt. Y to x dt, that would be equal to. So f of x minus f of y is less than or equal to m times x minus y. This is what? Lipschitz. If it is Lipschitz, it must be uniform. We are done. If it is uniform, it must be continuous. But no guarantee about differentiability. But I think we know from this theorem that this is differentiable as well. Yes.
First fundamental.
Yes. First fundamental theorem. Differentiability implies Lipschitz. Lipschitz does not imply differentiability. So I think now we can redefine the same proposition, but this is what we call the second fundamental theorem of calculus. So f is integrable on some closed interval a to b. Define capital F to be by f of x is a to x, f of t dt, then capital F is differentiable at u and f prime of x is equal to. Okay, is it okay? Should I remove this proposition? I think it is okay, and there is this short proof for it.
Sir, f of capital F is equal from a to b integration.
Are talking about this one or this one?
The upper one, sir.
Yes.
Yes. In the second line, sir, by f of x is equal to
Integral a to x f of t dt.
a to x
Yes.
or a to b.
A to x. A to some fixed x where x belongs to this interval.
Achha.
It is written here u, but this u is not there, this is x. X should be anything between a and b. Should I remove this one only?
Yes.
Okay. So are you okay with this? Second fundamental theorem of calculus. This is the, I think, the simpler form. There is also a general form of this one as well that you can see in calculus. That's very good. You have a function, you integrate from a to x, that is equal to some capital F of x. Then if you differentiate both sides, then you get this. If I give you an example, from a to x e raised to x square and dx, e raised to t square dt, this is, let's say, what is this? I have f of x to be integrated from a to x e raised to t square dt. First, what you need to do, you integrate this one, you put the upper limit, you put the lower limit, whatever you get, you differentiate. But it's not possible to integrate this function because it is not one of the elementary functions, we know very well. But we can apply fundamental theorem of calculus, the second fundamental. It says that, okay, the f prime of x is simply this f of x. What is f of t? E raised to x square. So what is f of x? E raised to x square. That's our answer. Nothing else. So our answer is, you don't need to integrate, put the upper limit, put the lower limit, just put the values and you are done. Are you agree with this? I think it's simple.
So lower limit for also बताइए.
Which one?
ये differentiate बना दे.
It's not differentiable
Okay.
because it's not the elementary function. So you cannot integrate it. That's the problem. Because it's not elementary function. But if you want to differentiate this, simply you can say in simple words that integration and differentiation are inverse processes. You may cancel the things and that's all.
Okay. Means
Your answer is e power x square.
limits भी इसी में जा रही हैं.
Yes.
Differentiate.
Upper limit x, it is there, but lower limit is a constant that is removed automatically. No need to write that. But let me write the final thing. Maybe the general form of this one. Let's say f1, not f1 of x, phi of x to, let's say psi of x, f of t dt. How to evaluate this thing? How to evaluate f prime of x? Can you help me in this one? First of all, what I need to do? I need to integrate this. Then I need to put upper limit and then lower limit, and then I need to differentiate. Okay. But the idea is very simple. You take this small f, evaluate with the upper limit f phi of x minus lower limit this, but multiplied by the psi prime of x multiplied by the phi prime of x. This is the generalized form. We'll do an example related to this and the things work.
इस एग्जांपल में x की जो differentiation थी 1 थी इसीलिए हमने उसको.
The differentiation of x is 1, so multiplied by 1, no need. The differentiation of a is 0,
Example number 1.
so multiplied by 0, this is. So it's the same as this one. But this is the simpler form, this is maybe the general form of that one. Okay, maybe do one example. The example is,
can we say that sir first fundamental theorem जो है वो हमें continuity and uniform continuity के बारे में बता रहा होता है.
continuity, yes.
और second
Continuity of capital F, differentiability. So if differentiability is there, there would be uniform continuity, no problem.
and second fundamental theorem हमें differentiability के बारे में बता रहा होता है.
Yes, that thing should be clear. Yes, yes. This thing tells us about the differentiability. This question has been appeared in so many tests. Either this or this type of question. You have to integrate e power x square, which is not possible. Then you have to apply the lower and upper limit. Then you have to differentiate. I am asking what is f prime of x. So you don't need to do anything. Just in this one, I am writing e power x square and e power x square. First you need to put the upper limit. What is upper limit? Put the lower limit multiplied by the derivative of upper limit. What is that? Then derivative of lower limit minus. That's an answer. E power evaluated at upper limit, so I put just x cube here. This square remains in. You can see f of phi of x. Then the derivative of psi of x, derivative of psi. So that's 3x square. Then evaluated on lower, multiplied by the derivative of this. So what this becomes?
3x square power
3x square e power
x power 6
e times 2 6 and 2x e power
x power 4.
x power 4. Maybe they rewrite this into some other notions as well. X e power
x power 4.
x power 4, 3x e power x power 6 minus x power 4 minus 2. Okay, rewrite but in whatever form you like. Okay, any question? This is the second fundamental theorem of calculus.